Hi students, today I will explain about real numbers for 9th class chapter 1. In before have to learn must learn about natural numbers, whole numbers, integers, rational numbers, irrational numbers. First I will go to natural numbers. What is the natural numbers? The number set which is starting from 1 to infinite. Then the number set is called natural numbers or the counting numbers. The counting numbers is also called natural numbers. The counting means 1, 2, 3, 4, 5. These are all counting numbers. The counting numbers is also called natural numbers. So natural numbers are denoted by n. Therefore, n is equal to the set of 1, 2, 3, 4 and so on. This is natural numbers. Next, whole numbers. The definition of whole numbers is 0 is added to natural numbers. 0 is added to natural numbers. Then it is called whole numbers. So whole numbers are denoted by W. Whole numbers are denoted by W. So W is equal to the set of 0, 1, 2, 3, 4 and so on. Okay. So whole numbers. 0 is added to natural number. Then it is called whole numbers. So whole numbers is equal to whole numbers is denoted by W. W is equal to the set of 0, 1, 2, 3, 4 and so on. These are natural numbers. Okay. Every number in natural number is a number of whole number. So n is subset of W. N is subset of W. N is subset of W means every number of natural numbers is a number of whole number. Okay. Next, integers. Integers. Whole numbers, integers. The definition of integers is the combination of negative numbers, positive numbers, including 0. The combination of negative numbers, positive numbers, including 0 is called integers. Integers are denoted by z. Integers are denoted by z. Therefore, z is equal to the set of minus infinite and so on, minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on, plus infinite. Plus infinite. These are positive numbers, positive integers. These are negative integers. Okay. So positive integers are denoted by z plus. Positive integers is denoted by z plus. Z plus is equal to the set of 1, 2, 3, 4 and so on. These are positive integers. These are negative integers. Negative integers are denoted by z minus. Z minus. So z minus is equal to the set of minus 1, minus 2, minus 3, minus 4 and so on, minus infinite. Okay. These are negative integers. These are positive integers, these are negative integers. What about 0? What about 0? 0 is neither positive nor negative. 0 is neither positive nor negative. Next, here observe the integers. These are whole numbers. These are 0, 1, 2, 3 and so on, infinite. These are whole numbers. So the number of whole numbers, every number of whole numbers is a number of integers. So W is subset of Z. W is subset of Z. Okay. So next I'm going to rational numbers. Rational numbers. The definition of rational numbers is the numbers which are in the form of P by Q. The numbers which are in the form of P by Q, where P comma Q belongs to Z, P comma Q belongs to Z, and Q not equal to 0. Q not equal to 0. Okay. The definition of rational numbers is the numbers which are in the form of P by Q, where P comma Q belongs to Z, Q not equal to 0. Here Q is denominator. Denominator must not equal to 0. Okay. This is definition of rational numbers. So rational numbers are denoted by Q. The rational numbers are denoted by Q. Q is equal to the set of x such that x is equal to P by Q, where P comma Q belongs to Z and Q not equal to 0. This is the definition for rational numbers. Okay. The rational numbers, every rational number can be represented as a decimal. Okay. Every rational number can be represented as a decimal. For example, 5 by 2. 5 by 2 is a rational number, and 1 by 2, 13 by 25, 5 by 3, 11 by 6, and 11 by 9, 17 by 6. These are rational numbers because these are in the form of P by Q, where P comma Q belongs to Z, Q not equal to 0. Okay. These are rational numbers. These are rational numbers. Next, what about 3? 3 is a rational number? Yes, 3 is a rational number. Why? Because 3 can be written as 3 by 1. 3 by 1. This is a P by Q form. Here P is 3, Q is 1. Here Q not equal to 0. So, this is in the form of P by Q. This is a rational number. 3 is a rational number. As well as 5. 5 is also a rational number. I will conclude that every integer expressed as a rational number. Okay, every integers as expressed as a rational number. Okay, so now I am discuss every rational number can be expressed as decimal. Okay, how to convert the decimal? Rational numbers converted into decimals. Now I will discuss how to convert the rational numbers into decimals. You have to take first example 5 by 2. 5 by 2. 5 by 2 means 5 is divided by 2. So you have to divide 5 by 2. 2 2 are 4. Here remainder 1. Have to take decimal point. Have to take 0. 2 5 10. Okay, what is the answer? The 5 by 2 is equal to 2.5. Okay, this is rational form, this is decimal form. Okay, so every rational number can be expressed as decimal. Next, second example is 1 by 2. 1 by 2 means 1 is divided by 2. So here dividend is less than divisor, so I have to take starting decimal point. Take 0. So 2 5s 10. Therefore 1 by 2 is equal to 0.5. This is the decimal. The rational number converted into decimal. Next, third example is 13 by 25. 13 by 25. So 13 is divided by 25. So 13 is less than 25. How to take point, decimal point, like 0. So 25 5s. 25 5s 125. Remainder is 5. Take again 0. 25 2s 50. Okay. So 13 by 25 is equal to 0.5. Okay. Next take for the example. 5 by 3. So 5 is divided by 3. 3 ones 3. Remainder 2. Take decimal point. 0. 3 5s. 3 6 18. Again remainder 2. Take 0. 3 6 18. This is continuous. So therefore 5 by 3 is equal to 1.666. That is equal to 1.6 bar. 1.6 bar. This is a decimal. So 5 by 3 can be expressed as 1.6 bar. Next, 17 by 6. 17 by 6. So 17 is divided by 6. 6 to 12. Remainder is 5. Take decimal point. Take 0. 6 8s 48. 2 is remainder. Again take 0. 6 3 is 18. 2 again 3 is 18. This is continuous. So 17 by 6 is equal to 2.83 bar only. 83 bar. So these are rational numbers can be expressed as decimals. How to observe these decimals? In this decimals, two types of decimals are there. Here division is handing, division is not handing. Okay, so here decimals are two types. Decimals are two types. First one is terminating decimals. Terminating decimals. Second one is non-terminating decimals. Terminating decimals. Non-terminating decimals. First one is terminating decimals. Second one is non-terminating decimals. So what is the terminating decimals? The terminating decimals are those numbers, for example 2.5, 0.5, 0.52. In these decimals, those decimals come to an end after few repetitions after decimal point. These are terminating decimals. In this case, 1.6 bar and 2.83 bar. This is continuous division. So these are called non-terminating decimals. Okay. So here non-terminating decimals, again two types. First one is non-terminating recurring decimal. Next, second one is non-terminating mixed recurring decimal. Okay. So decimals are two types: terminating decimals, non-terminating decimals. Again, non-terminating decimals also two types: non-terminating recurring decimal, non-terminating mixed recurring decimal. This is non-terminating recurring decimal. Here recurring decimal is 6. Next here 2.83 bar. So here 3 is the recurrent. So this is mixed recurring decimal. So here non-terminating recurring decimal is 1.6 bar. 1 point, for example of non-terminating recurring decimal 1.6 bar. Non-terminating mixed recurring is 2.83 bar. Here mixing decimal, recurring decimal and non-recurring decimal. So here 2.83 bar. So this is non-terminating mixed recurring decimals. Okay. So another decimals also there. That is non-terminating non-recurring decimal. Non-terminating non-recurring decimal. The definition of non-terminating non-recurring decimals is this is continuous endlessly. Decimal points are continuously, endlessly. The group of digits also endless. Okay, this is non-terminating non-recurring decimals. For example, the value of root 2 is equal to 1.4142, 135 and so on. The value of root 3 1.732, 2050 and so on. In the same way, the value of pi is 3.14159 and so on. So these are non-terminating non-recurring decimals. So this is continuously divisible, continuously recurring decimals. So non-terminating non-recurring decimals. This type of decimals is also called irrational numbers. Okay, this type of decimals is also called irrational numbers. So irrational numbers are denoted by q dash. Pi is not a rational number. This is a irrational number. Okay, so irrational numbers is also represented by q dash. Okay, this is irrational numbers. The example of irrational numbers is root 2, root 3, root 5, root 6, root 7 and so on. Here root 1, root 4, root 9, these are not irrational numbers. Why? Because rational numbers, root 1, the value of root 1 is 1. The value of root 4 can be represented as 2 square, that is equal to 2. Here root 9 is also 3 square, root square root of 3 square, that is 3. Okay, so these are rational numbers. Root 2, root 3, root 5, root 6, root 7 are irrational numbers. Okay, next I am going to the next number set is real numbers. So the real numbers, the definition of real numbers is the combination of rational numbers and irrational numbers is called real numbers. Okay, so R is equal to Q union Q dash. The combination of rational numbers and irrational numbers is called real numbers. Real numbers is represented by R. Okay. Real real numbers can be represented as a diagram like this. This is a real number set, natural numbers, whole numbers, integers, rational numbers. This is Q dash, irrational numbers. The combination of rational numbers and irrational numbers is called real numbers. Okay, this is Venn diagram of real numbers. So every element of natural numbers is a element of W. W is subset of Z. Z is also subset of Q. Okay, so here N is subset of W. W is subset of Z. Z is subset of rational numbers. Rational numbers is also subset of R. Okay, N is subset of W. W is subset of Z. Z is subset of Q. Q is also subset of R. Okay, again Q dash. Q dash is also subset of R. Okay, the real numbers is equal to the combination of rational numbers and irrational numbers is called real numbers.